So let's start with the most superficial structures that you can see even without making cuts. So when you skin the cheek region of the cat up to the ears there, you've already revealed one salivary gland there. That's the parotid salivary gland, the largest salivary gland. Okay, this is a muscle. This is part of the platysma, a dermal muscle of the facial skin, and serves to move the skin in the face for changes in facial expression. And if you reflect it like that, you can immediately see next to the masseter is the parotid salivary gland. And just ventral and posterior to it is this large organ or gland here. This is the submandibular, also called as the submaxillary salivary gland. Okay, this is different from these two. Don't confuse it with these two. These two are lymph glands. So they're part of the lymphatic system, immune system actually. They're not salivary glands. This is the submandibular salivary gland. Right, the next is the sublingual gland, and it's a deep structure and located anterior and deep to the submandibular gland. And when you see it, it looks like an anterior portion of the submandibular gland, but it's actually a separate gland in and of itself, the sublingual gland. So let's look for it. How do you look for the sublingual gland? You can look for it here, and that gland is so deep, it's actually covered by the digastric muscle. And so one way you can dissect it is by first cutting the belly of the digastric and reflect it and see the deeper structures within. And so once you've done that, the sublingual gland is here. Let me see if I can focus. So this one, the one beneath the probe, is the sublingual gland. So it's really tough to dissect. It looks like a muscle, but you have to practice distinguishing the texture of a muscle and that of a gland. They have a subtle difference, which is better studied or learned in actual lab activities rather than by viewing a video. But that's the sublingual gland there. So remember, this is the submandibular. So it's deep and anterior to the submandibular. This is the sublingual. And they actually share a duct. So the submandibular gland will secrete saliva in order to help with carbohydrate digestion to its duct. And then that duct will also receive the secretions of the sublingual salivary gland. And so this is the duct, that white line. So that duct will receive both the secretions of the submandibular and sublingual, and will empty into the mouth near the base of the tongue. So this is the tongue. If you lift it, and look, so there, so we're at the base of the tongue, and there are two papillae there, two little knobs, anterior region of the jaw. There are two little knobs. Those papillae are the location of the ducts ng salivary glands, ng submandibular and submandibular and sublingual, sorry. So yun, dun nila sinesecrete yung saliva, right? And then that's the third salivary gland. The fourth one is the molar gland, and as the name implies, it lies close to the molars. And in order to see it, you will have to skin the margin of the mandible. So this one is already skinned, and you can see that there's a brownish structure here. It looks like a muscle, but it's not really a muscle. This is the molar gland, another salivary gland. Okay, there's a fifth salivary gland, the infraorbital, but we won't dissect it because as the name implies, it's inside the orbit. And so it's difficult to dissect. But suffice it to know, there's a fifth infraorbital salivary gland. And so those are the salivary glands ng cat. We next look at the structures within the oral cavity itself. And in order to facilitate that, you will have to break the cat's jaw, like so. But you won't break it on both sides. One side will suffice. So you will have to use some kind of a tool, a cutting tool. You use the bone cutter we have here, and essentially cut it, this one of the rami ng mandible, break it, and then you push it like so with the help of some rags or cloth para hindi kayo ma-injure ng teeth. And then with the help of a cloth, you push the mandible like that. What you want is for it to give way like this. So mapuputol talaga siya, mag-break siya, the mandibular symphysis. You can see nahati na yung mandible niya through the mandibular symphysis. So that's what you want actually in order to view the oral structures there. So what are the oral structures? You have to know there's the lips, there's a cheek, the cheek, which is just a flap of skin surrounding the lateral walls of the oral cavity, the cheeks, lips. This would be the teeth, obviously. And then the space in between, there's a space in between the teeth and the lips, where our gums are located. That's the vestibule. And then obviously there's the tongue. The tongue at its base has a flap of tissue linking it to the base of the oral cavity. And that connective tissue that connects the tongue to the floor of the mouth is the lingual frenulum. Right? Lingual frenulum. And then the roof of the mouth, or the oral cavity, is formed by the secondary palate, which is different from the primary palate. Remember that only a few vertebrates would have evolved real secondary palate. Another example would be the crocodiles, crocodilia. And mammals, one of its defining feature anatomically would be the possession of a secondary palate that separates the oral cavity from the nasal cavity. Okay. But in mammals, the secondary palate has two portions. This one is hard, the anterior one. So that's the hard palate. Okay. But if you move posteriorly, it's not made up of bone anymore. It's soft. Okay. Soft tissue. So that's the soft palate portion of the secondary palate. Right, so next we examine closely the tongue. The mammalian tongue is also called as the definitive tongue. This is in contrast to the tongue of fishes like the shark, which is called the primary tongue. And unlike the primary tongue, the definitive tongue has unique properties. Like first, it's invested with skeletal voluntary muscles, so it's mobile, and it's also sensory, so it has sensory innervations that help the animal taste its food, for example. And what else? In some cases, it's also secretory, so may mga secretory cells in the tongue. For example, mucus secretions. So it's mobile, it has muscles, and it's sensory. Those are some of the unique features ng definitive tongue of the cat. When you look at the dorsal portion of the tongue ng cat, there are minute structures there called papillae. And there are different types of papillae in a cat. Their morphology is related to their function. But you only have to know 3. So yung mga backwardly oriented spines na yun are the filiform papillae. And they have a mechanical function actually. It's for scraping. It's good for scraping. The filiform papillae are actually what makes the cat tongue rough, like sandpaper. So it's used by the cat to scrape off bones from its meal. It's also used by the cat to groom itself. So it serves kind of like a comb. So pinanggugroom din yan ng cat. And cats do tend to groom themselves frequently. So those are the functions ng filiform papillae. And another type of papillae are the fungiform papillae, which are not spiny like the filiform. But it's difficult to see in our specimen due to the limitations of my camera. So maybe I'll just share a picture or a diagram or something on your screen to help you visualize it. But let me try and show you. They are circular. They're not spiny like the filiform. And they are less dispersed, less numerous. Like they're sparse in distribution. Yung fungiform. So that's one. Look at that one. That's not spiny. That's just a circular knob. So they're just scattered. That's another one. That's a fungiform papillae. Okay. And the third papillae is the valate papillae, and they are mainly restricted sa posterior portion, and they are arranged in a V configuration. I'll just show you a close-up picture of the papillae ng cat. So there's the filiform, the fungiform, and the valate papillae. And in general, papillae have a few functions. One is they increase the surface area for chemoreception. They are equipped with taste buds, so they have a sensory function. And some papillae, like the filiform papillae, have a mechanical function for scraping food, and for grooming. Yeah, that's it for the oral cavity. So now we move posteriorly to the pharynx. If you move posteriorly, you are now in the domain of the pharynx, and the pharynx, due to the evolution of the palate, has been partitioned into at least 2 compartments. So the part continuous with the oral cavity is the oropharynx. And the one dorsal to the palate is the nasopharynx, continuous with the nasal cavity. Makes sense, right? Their names. Right? So this would be the nasopharynx, and this continuous with the oral cavity is the oropharynx. And this is the soft palate, which I have already incised in order to view the nasopharynx inside. If you trace the pharynx anteriorly, you will eventually reach the internal nares, right? So if you remember yung skeletal unit natin, the ventral view of the cat skull shows the internal nares, which leads to the nasal cavity. So this is the nasopharynx, which will lead to the internal nares, and then eventually up there you will reach the nasal cavity. And if you open the nasopharynx, you should be able to see a paired slit, which should indicate the location of the auditory tube canal, or the eustachian tube, which links the middle ear cavity into the pharynx. So let me try and show you those slits. This is another structure that is difficult to show. I don't think it's showing in the camera, but I can see it from here. There are two slits there, dorsolateral inside the nasopharynx. But suffice it to know that those slits are the openings to the auditory tube or eustachian tube, which links the middle ear cavity to the nasopharyngeal cavity. So and it serves to equalize the pressure inside your middle ear. So that's the functional relevance of the auditory tube opening. So if you want to see it, just look for it during our face-to-face lab activity. But that's one slit there na ayaw talaga ipakita sa camera. Okay, medyo madilim. Anyway, next structure you should look for near the dorsolateral wall of the oropharynx. So we're in the oropharynx. There's a little knob-like structure again there. That's a tonsil, specifically the palatine tonsil. And it's located inside a fossa, a cavity. So that nook kung saan located yung palatine tonsil is the tonsillar fossa. Yung kanyang depression that contains the palatine tonsil is the tonsillar fossa. And palatine tonsils are part of the immune system, first line of defense against infection. And the tonsil is actually bounded by two arches, which you can use as an anatomical landmark to delineate the boundary between the oral cavity and the oropharyngeal cavity, kung saan nagsisimula yung pharynx. And the arch anterior to the palatine tonsil is the glossopalatine arch. It's named so because it's connected to the base of the tongue and to the palate, glossopalatine arch. And then the arch posterior to the tonsil is the pharyngopalatine arch. So glossopalatine arch, pharyngopalatine arch. In between them is the oropharyngeal cavity. And this is the tonsil. Right, and we move more posteriorly. And we're now going to examine two tubes there. So after the oral cavity in the oropharyngeal cavity, you will now see two passageways, right? This one, dorsalmost tube, leads to the esophagus. That's where food goes in water. The more ventral tube leads to the trachea or the windpipe. So that's where air goes. Okay? So bale yung air coming from the nasal cavity to the nasopharynx should go to this tube, whereas the food and water coming from the oral cavity and then the oropharyngeal cavity should go down this tube, okay, the esophagus. And this process is tightly regulated by reflex actions such that one material like food and water will not go down the wrong tube, right? And one structure that helps you do that to prevent the food and water going down the trachea, the windpipe, is this one. This flap of cartilage, elastic cartilage, is called the epiglottis. And thanks to this, it closes the opening into the windpipe. The opening is the glottis. That's the glottis, the opening. And the epiglottis, above it, closes the glottis when you are swallowing food and water, so that it will only go to this tube, the esophagus. Right. Now we examine the larynx. The larynx is just the anterior portion of the respiratory tract that is surrounded by cartilages. Okay, so this region here is the beginning of the respiratory tract, and it's surrounded by cartilages. The first cartilage you have already met during our study of the neck and throat muscles. The largest laryngeal cartilage, and its shield shape, also called as the Adam's apple. So in order to see it, you just have to reflect the strap muscles of the neck, like the sternohyoid. And then this white cartilage here and broad is the thyroid cartilage. And then just posterior to it is a thinner ring-shaped muscle. This is the cricoid cartilage. Cricoid cartilage. It looks narrow and ring-shaped ventrally, pero it's actually broad on the dorsal side of the larynx. So thyroid cartilage, posterior to it is cricoid cartilage, ring-shaped. But cricoid cartilage is actually broad. If you can dissect the larynx really well, you will be able to see there's a cartilage at the back side of the larynx, and it's broad. That's the dorsal portion of the cricoid cartilage. So it's broad at the back, but only thin and ring-shaped ventrally. And then another set of cartilages, the larynx, guard the glottis opening. These are the arytenoid cartilages. Arytenoid cartilages. There are two arytenoids there guarding the glottis. And then there are lateral folds partially blocking the glottis, the airway. Those are the vocal cords, helping the animal produce a variety of sounds for vocalization. There are true and false vocal cords, but it's better to study and differentiate them during face-to-face activities, as they are difficult again to show in the camera. It's dark down there, but there are folds partially blocking the glottis. Those are the vocal cords. Right. And then we go more posteriorly. So this is the larynx, kung saan the anterior portion of the windpipe na surrounded by the cartilages. Then if you move posteriorly, you reach the windpipe itself, the trachea. And the trachea has a distinct appearance. It is reinforced by rings of cartilages. And meron siyang parang horizontal white stripes na yan. Those are rings of cartilages reinforcing the trachea so that it won't collapse under negative pressure ng air. Right? So that's the trachea. But what's interesting is that the trachea, although it is reinforced by rings of cartilages, it is incomplete. Right? On the dorsal aspect of the trachea, there's no cartilage. And that's because at the backside of the trachea is the esophagus. And so it's beneficial not to reinforce the backside of the trachea in order for the esophagus to expand when you're swallowing. Right? So the trachea is only hard on the ventral side, pero on the back side it's soft and pliable. There's no cartilage on the back side of it, so that the esophagus can expand as it allows the passage of food and water down into your digestive system. I forgot to tell you and show you a pair of lobular structures beside the windpipe and just before it enters the chest cavity. And as shown in the diagram, these are the two lobes of the cat's thyroid gland. In the case of the cat, the gland is split into two, the left and right lobes, unlike in humans. And the thyroid gland is essentially an endocrine structure, and it secretes very important hormones for control ng growth and metabolism, and also has a role in development. There's this last structure I almost forgot. This is a bone located just anterior to the larynx. So remember, this is the larynx, and then just anterior to it is a bone. You're familiar with this. This is the hyoid bone, right? The hyoid bone. And when you break open the jaw, you will probably see one of its horns. One of its horns there. Let me look for it there. It's one of the horns. One of the horns peeking out. Nung kinat open mo yung jaw, one side of the jaw, essentially you've also cut that and one of the anterior horns of the hyoid bone. That long horn there is the anterior horn, and then the shorter horns there are the posterior horns. And that horizontal bone there, as indicated in this diagram, is the body of the hyoid, or basic hyoid. Posterior horn, anterior horn, basic hyoid, or body of the hyoid. And then the anterior horn actually reaches to the skull, connects to the tympanic bulla of the skull, somewhere here. Right? Whereas the posterior horns are linked to the larynx. So the hyoid bone serves to mainly support the tongue and also serves as an attachment for neck muscles like your sternohyoid. You see, from the sternum attaching somewhere here, because this is the location of the hyoid bone. And that's it. That's the last structure you need to examine in the oropharyngeal cavity. Coming next, we open up the pleural cavity and look at the structures contained inside.